Wishing you a great week. Enjoy the show, and please warm welcome to CEO of ENCY Software, Andrey Kharatsidi.
Hello everybody for coming this year. We can see that this year we had even more people than previous years, and there are a lot of people who made their very long trip from other parts of the world, and we are very excited about this. So thank you for coming, everybody. And now let's move on to some numbers. So for those of you who had faced software development, I think we have these guys in the room. When you see what you feel when you see 3.5 million lines of code, it's a huge software. Okay, it's enormous. It's like I don't know how to say. It's like it's a very big software product. However, all companies who have this legacy with their code face the same problem at some point. They cannot make changes in the software because everything is too complicated. A couple of years ago, we overcome this problem, and now we can say for sure that we can develop our software very fast, okay, make any changes anywhere, and we experience virtually no limitations on what we could do with our code. I know for you, maybe it doesn't sound very inspiring, but for me, believe me, yes, it's very important. Okay, and this is also why do we have new features every year, and these features are not just changing the version number, like some companies do. No, we put real new possibilities to our software every year, and we are able to develop it very fast because we have control over this 3.5 million chunk of code. Okay, next. Just some numbers about our scale for understanding. So per year we have, it says 940,000 launches, but in fact it's more than 1 million launches per year. Because we are not calculating all of them, okay? These are just the ones we can see, but there are a lot of people using software offline, so we're sure that we have 1 million launches per year. Also, we have almost 22,000 unique users over the world. And this year, during previous year, we issued 13,000 trial licenses and 3,000 commercial licenses. This is just for understanding, for your understanding of what numbers do we have as a CAD/CAM software. Okay. And as a result, okay, during last year, okay, during last 12 months, we experienced 40% growth of sales, of revenue of the company. Is it a big number? Yes, of course. It's a very serious result. Thanks to you guys, thanks to our team, thanks to our sales team, thanks to our business development team, to our marketing team, our development team. Everybody is working 150% in our company. Okay. At the same time, I would like to say that still we have a very big potential. In my opinion, this is absolutely realistic that we have not 40%, but 140% every year, maybe 240%, because I'm sure that our products have perspective and have potential to gain this growth next year. So you came to the conference, and I hope, okay, and for some of you, I'm sure that after the conference, you will go back home and you will have a clear picture of what are you going to do next year. Okay, clear steps of how you make this growth not 40%, but 100% for your own company, and as a result for us also. Fine. Now, I would like to speak a little bit about our products, because we have new people here, so for them, this is for them, but also for those of you who maybe are not familiar with the whole lineup of the products, this also will be useful, I think. So let's have a quick walkthrough and see what we have. So first of all, yeah, of course, ENCY CAD/CAM software. This is clear, okay? CAD/CAM for a new generation. If I need to explain and to describe this product in one sentence, this is it, okay? Delivering sophisticated CAM technology in an intuitive user interface and natural workflow. Why is that important? Because some guy in the internet, I read the comments in the social media. He started using ENCY like several months ago, and he said, "Okay, this is a technological monster." Okay, and I agree with that. At the same time, we always keep our attention and always focus on the interface in order to keep the workflow as simple and as intuitive as possible. And I believe if we multiply these two factors, the technological complexity and the interface intuitiveness, we get the quality of the CAD/CAM software as a multiplication of these two factors, okay? Because it's very easy to put more and more and more buttons in the interface, and you will end up with like 150 buttons on the screen, and you don't know what to do, how to use it, and then what's the case with this old technology if you don't want and if you don't know how to use it. So this is important for us. Next. Our second product, which is, as I say, equally powerful, is ENCY Robot. This is an offline robot programming platform. Okay, and it says, ultimate toolpath calculation, kinematics management software for industrial robots. A couple of words about ENCY Robot. It's very different from ENCY for CNC machines. Because when we initially released software for robots programming, we said, okay, we put all the CAD/CAM technology, and now it's in this software, and now it's available for robots. Okay, by itself, it's already impressive, but the thing with robots is that robots have more complex kinematics, and you need some additional tools to manage these kinematics. That's why traditional CAD/CAM software cannot program robots. Those of you who make robot programming understand this very well. So we put some additional algorithms, not simple ones, okay, to manage redundant axes. Like robot by itself has 6 axes, then you have like a rail, positioners, blah blah blah. You may have like 18 axes in the robotic cell, and you need to somehow program all of them. Okay, and for the toolpath you need only 5. So what do you do with other 11? So this is the solution for this. And by the way, also after we released robot programming solution, ENCY Robot, we also put there some specific robot technology like welding, painting, some other things. Okay, so next, ENCY Tuner released last year, and this is our view on the shop floor simulation software. What's special about ENCY Tuner is that it's natively compatible with all our products, so you can take the project from ENCY, open it in ENCY Tuner, and see the simulation. For the guy on the shop floor, I think it's very important because he will not need to spend his time to understand what's in the ENCY code which someone sent to him. He just can open the project and see the simulation instantly. Okay. Of course, we have put there some direct ENCY code editing tools. Okay, not so complex, but still very useful for operators. Okay, and the very important thing about ENCY Tuner is that it runs absolutely same simulation engine. So it's 100% like consistent. What you see in ENCY, 100% guarantee you see the same in ENCY Tuner. Okay, because they're using one code. Okay, one simulation engine. Everything is 100% the same. This is important. Next, last year we also introduced ENCY Clouds. It's a digital, how we call it, cloud-based digital workspace for CAD/CAM engineers. Okay, you saw in the video before. This is kind of thing which is connecting everything, okay? Connecting workspaces of CAD/CAM programmer, of technical support, of the developers, of machine operators, robot operators. Everybody has now connected environment, can exchange projects very fast, not using any Google Drive, emails, whatever, and get the notifications on the phone, which is also time saver and helps people to communicate faster. So this is good thing, and we will have ENCY Clouds masterclass during this conference. Please attend it. I'm sure you will be able to experience yourself, and I'm sure you will like it. Okay, this is another thing. Okay, very important thing which we made a preview last year. Okay, but this year we already have a commercial version of ENCY Hybrid. This is a hybrid robot programming platform. Okay, it may look very simple, but underneath, it's an extremely powerful thing. This is our view on how robots should be programmed. Okay, with this product we overcome all the limitations of traditional offline programming, combining online and offline, so that in a proper way, okay, as we see it. Some of you I know have already experienced a demo version of ENCY Hyper, and during the conference we will have a separate presentation about this. This is very important for robots programming, in my opinion. Fine. Now, NCX. Maybe you still have some confusion about this. I would like to remove this. So first of all, I would like to say NCX is not a product, okay? It's more of a concept, because this is something which makes us different from other CAD/CAM software, okay? This leads us directly to the theme of our conference. So people, our customers, are working on the production level, and they are real heroes. And our mission is to provide them the superpowers with our software solutions. And with NCX, we help turn everyday heroes to superheroes. Fine. Now let's move on to the main part, ENCY 2.0. I think all of you are waiting to see what's underneath, what are new things what we present this year. So now you will see it. So please stay with me. This is the main part. I hope you had enough coffee in the morning so that you stay focused, okay? Fine. So every year we introduce many new features and improvements, okay? The product is changing very fast, and we have a lot of new features every year, and this year is no exception. Okay, I would like to say that every year we really very attentively listen to your feedback and your requests, and I'm sure some of you will see, okay, I requested this 1 year ago, now I can see it in the software, okay? And also we collect feedback from our end users, of course. We have our own vision, okay? And all in all, we make a decision taking into account all these factors to have a product strategy and to move forward, okay? So, first of all, first thing I want to say is in ENCY 2, we have a completely new homepage. This is now the ENCY main window, okay? So, this is what our customer and our user will see. First of all, what you can already see that we visualize all the recent projects. It's very easy to navigate now. We have proper integration with the cloud library. In the cloud library, we introduce collections, so you can put the projects into collections. You can use it for demos, for example, mill-turn projects, put it into collection, get a link, send to the customer, he can see it in a preview. What's the preview, okay? Like, for example, we can see, okay, this is the project from Italy, I believe. So if I click the preview, on the preview, we have all the project metadata. We can see who is the author of the project. It's from Spain, sorry. Yeah. What the machine is used, what are the operations in the project, okay? Setup, tools, everything. And we even can preview the part, and we will also make a visualization of the toolpaths. So, and this you can do without opening a project and without actually opening ENCY, because it's just a homepage, okay? You can have it as a separate application. Fine. And here, yeah, we have ENCY, standard thing, okay? Standard, like ordinary thing which you are used to. And if I want to open the project, I just click this button. So now the project, this is a cloud project. It's just got downloaded from the cloud, and now you have your project in front of you, okay? One more important thing about homepage, now you have the maintenance notification on top. So we believe this will be, for you, it will be easier now to sell maintenance to the end users, because they are always aware of how long of the maintenance is left, okay? So, what are the highlights? Okay, quick access to personal and shared library projects. Okay, preview of the projects, easy access to collaboration sessions. So all the cloud sessions are always also available from the homepage. Maintenance banner. Okay. What I want to say here is also we have some future plans to put their machine library, post-processor library, 3D models, everything. And during the conference, maybe you have some ideas. So please tell us. Okay. What else can we put on the homepage? What are the good things to put, because you know better how customers work, okay? And maybe you have good ideas for this, so we would like to listen. Let's move on. So initially, ENCY was introduced in the dark theme. Okay, I think that this is a good idea, and I like dark theme very much. Okay, but there are still 5% of people who don't like it. Okay, and if during version 1 there was a problem, yeah, the absence of light theme was a deal breaker for you, now you have an answer to this. Okay, you just have light theme now, so you can switch dark and light theme. They both look good, okay, and it's very easy to switch in the settings, and you can use either of them. Okay, still I want to say here that we are going to use dark theme as the main color of the software, okay, and put all the videos in the social media internet with the dark theme. Light theme is an option, okay, let's say. Fine. Next, here comes the main parts, okay, here's the main thing beginning. So, many of our customers work with mill-turn machines, okay, we know it for sure. And thanks to our machine-aware technology, we have secured a strong position on this market, okay? But we are making next step, and today we introduce tool assemblies. This is a requested thing, which was requested for a long time. So now you can create full tool assemblies, combine holders, adapters, whatever your components you have for the cutting tools. And I believe that this new capability elevates ENCY to entirely new level, and it's a really important thing. So let's take a look at a quick demo. So here I have the mill-turn machine. You all know how it looks. Okay, and now on the turret head, right here on the screen, I have interactive elements which I can use to create my tools. Okay, you already start discussing something, yeah, about this. I can hear that. So right on the screen, without going anywhere, I can just combine my components, okay, which I have in the library, and create tools for right spindle, for left spindle, lathe tools, milling tools, whatever kind of tools is required for this project, okay? Like this, you can combine not only 2 components, but any amount of components. Like this, for example, we have 3 components here. Okay, and I can very easily and very fast, I can create the whole setup for the turret head, okay, without going anywhere in the same window which I use to create the project. This is how we see it, and I think this is a proper way how this complex machine setup should be done, okay, because you don't need to learn it, okay, you just do it right from the beginning because it's intuitive. Okay, so you see, like 30 seconds, I can create a setup, okay, with different tools on the turret head. Okay, and also, of course, I have a milling head in this machine, so I can use the same approach to create a tool for milling head. Actually, I can put there also lathe tool, no problem, or milling tool, whatever. So this is it. Next, when you create an operation now knows which tools from the setup are applicable, okay? And in the lists on the dropdown, you have only the tools which you can use for current operation, for current spindle, okay? From the setup that you already have. And we have now we have a separate window, okay? This is it. Sorry. Need to move it a little bit. Okay, so this is a components library. Okay, here we have all possible types of connections from all the tool manufacturers. Okay, you have tools here. They are interactive and parametric. You can create your own tools, or you can import tools components from the machine from tool builders libraries. Okay, so and also here on another tab, you have your machine setup. Okay, you can do it from here, or you can do it right from the main screen. What's important here is that when you finished with your setup, you can save it and use it for other projects, of course. Okay. Yeah, you have save and load options. Okay. So this is the main items, the main thing I want to show about the tool assemblies. So what are the key highlights? So now you have tool assemblies, first of all, okay? Second, you can import 3D models or create your own. If you don't have a 3D model of the tool, no problem. You can just use our embedded CAD to make quick modeling. Okay, no, absolutely no problem. You have a very, very detailed visualization, not only actually visualization, because it's tool assembly geometry is used for collision detection, very important. So now you have precise tool assembly and all its components, and it's used for toolpath calculation and for collision detection. Okay, interactive interface, very important thing. Okay, it's very complex thing for a CAD/CAM software. Okay, it's not a easy thing which you can do like very easily. No, it's a very, very, very complex functionality, but we managed to keep it intuitive, so we virtually don't have any learning curve for this. You just open, you understand instantly how it works, just use it, that's it. At least we hope our users will understand. But at least I can say that everybody in our company understood instantly. Second topic I want to discuss today and want to talk and show to you is feeds and speeds. Okay, now in version 1, okay, previously in version 1, actually, we had a limitation. One tool had one set of cutting parameters. This is okay, but for some situations in the real world, this is not convenient and this takes time. Maybe customers make errors and this is not what we want. So this year we came up with a whole bunch of upgrades for feeds and speeds. So first of all, we introduced feeds and speeds calculation. We say table, but it's not a table, it's actually algorithm. So now you have a separate tool or separate window where you can define everything. So for example, workpiece material, tool coating, okay, material, and also technology, machining technology is also considered when the feeds and speeds are selected. And what's important to say is that now everything is stored in the right place. For example, workpiece material is in the properties of the workpiece, okay? Technology is an operation, and some tool material, okay, and tool parameters inside of the tool. So now everything is put in the right place, all connected together. And also I want to say that you can import, of course, now the tool libraries, feeds and speeds from tool libraries, okay? And also interpolate these feeds and speeds, because in real life, in real projects, we always have some position between the lines of the table. You need to define what's the actual feeds and speeds will be in my project. So we have an interpolation, so you can put your feeds, define your feeds and speeds precisely now. Second, material removal rate graph. Okay, this was relatively easy for us to implement, having on the background, having the fact that we have our own simulation engine, so we have all the information. Now you just can open this window and see how is material removed throughout the toolpath, okay, for any toolpath. Let's take a look, a quick demo. So here is a typical project, okay. I can just open this window and instantly see, okay, what's the material removal rate, and when I drag the mouse along the toolpath, I can see in the simulation at the same time. Not simulation, but tool movement, okay? So I can visualize in which area of the toolpath is the particular material removal rate takes place. You can use this, okay, before you launch the ENCY code, in order to make sure that you're on the safe side, okay, you know how your tool will work throughout the toolpath, okay, and also we don't have any algorithm to change the feeds and speeds on the operation, but I think this will be the next step. And also, I think this is a huge thing for ENCY Tuner also, because you can diagnose your ENCY code, third-party ENCY code with this tool very easily and see how it works. Next, corner feed control. This is relatively easy thing, but also requested, okay, very much. So now you have a possibility to define gradually how the tool gradually slows down and accelerates while going through sharp corners. Actually, not only sharp corners, but also small arcs are also possible. So let's take a look. Here is a typical situation. We have the toolpath, contouring toolpath, okay, and we have two lines of code, okay. So we have constant work feed, yeah, and we can see that the tool is going through this corner on the constant speed. This is not what we want. So we enable corner feed control. There are all the parameters you need. Okay, you can define the number of steps, the percentage of slowdown, everything, step length, everything. Okay, let's recalculate the toolpath and see the result. I think it's clear for you, but let's take a look. So now we have several steps, okay? The initial work feed is 2000 still, but the tool is gradually slowing down and then accelerating. As easy as that, but I think very important for certain situations. Next, feed control for crossed holes. Okay, this is another situation when we need to precisely control feed rates, okay, because if we don't, we have problem, okay, we can break the tool, we can not make the proper precision. And during the conference, we will have a separate presentation from our dealer in Germany about this feature. He will tell more details. I will just go ahead for now. You will learn about it later. So all in all, feeds and speeds are now very different in ENCY version 2. A lot of changes, okay? Cutting parameters table, interpolation of these cutting parameters, material removal rate graph, corner feed control, a lot of things at the same time we did for feeds and speeds. I think this also will push ENCY to the new level for some customers. This is critical, this is very, very important. Next comes the robot theme, okay? I think some of you have been waiting for this, so here we are. First of all, I want to say, yeah, we had for several years, we had our collision avoidance algorithm. In some situations, it works quite well, okay? But as you all know, in some situations, it struggles. And even if it works well, it's quite slow and making the toolpath, which can be scary for people, you know, when the robot is like moving very fast and there is a very, very small gap, people don't like it. But still, it's correct toolpath, it works, but people want a little bit, you know, on the safe side. So, we completely re-engineered collision avoidance algorithm. Not actually re-engineered, it's a new thing, okay? We build it from zero. Completely different approach, which takes into account not the local part of the toolpath, not the local area, but the whole toolpath, okay? It works on a different principle, and the main thing is it works now very fast. And this allowed us to build something, in my opinion, very exciting, okay? I will show you in a moment. So, thanks to the new collision avoidance algorithm, now we have automatic robot axis map. Those of you who make robot programming know it for sure. But in some situations, for example, in this situation, when we have a robot on the 3-axis gantry, it's quite challenging to do it. Especially, it's quite challenging to teach customers how to use it. So now you don't, okay? You don't have to do this. So let's take a look. Here is a typical situation. We have a robot, 6-axis robot on the gantry, okay? 6-axis of the robot, 3-axis of the gantry, okay? 9-axis all in all together. We also have a 6-axis toolpath here, which is also complicating things. But no problem. Yeah, let's first calculate the toolpath as is, okay? As it's usually happens. So we calculated and see, okay, we have a lot of problems. Like, everything is red. We have overturn, which means we run out of the limits at some point and some axis. We open the robot axis map and now have to like spend quite a lot of time trying to avoid all these collisions. Yes, it's visual, yeah, but the problem is when you have like 4 tabs of it, it's not so good. So now there is one magic button. You just enable it, calculate the toolpath, okay, and that's it. Okay, you have toolpath optimized, everything is collision free. So I think this feature alone is already enough for ENCY Robot version 2, okay? But there are more things coming. So, automatic robot access map. What's very important, okay? Yeah, it's automatic now. You can say to tell your customers, here's a magic button. You click it, you have the toolpath. After that, you can tweak with the robot access map if you want, but you have already the toolpath, which is collision free, which you can run on the robot. It will work, okay? And also very important is that the calculation time is very fast. So yeah, it takes some time, but it's quick, okay, I would say. And one more important thing about this automation is that now the automatic axis robot axis map, automatic robot kinematics calculation, will put our API solutions, okay, for the next level, because now you don't have to force user to interact with the software when you calculate the toolpath for robot, which means you can use ENCY on the background to calculate toolpaths and be sure that the kinematics in this toolpath is managed okay. So you can just run simulation and run the program, okay, without interaction of the user with the main interface. I think this is very important. Here comes the smaller features, but still very important, okay? First of all, every year we make changes in our 5D surfacing algorithms. I will say again, this is our proprietary algorithm developed internally, 100%. We are not using any other code, any other algorithms, any third-party things, okay? We have full control over the source code, and this helps us, and this allows us actually to make any changes we want, okay? And direct our development in the proper direction, okay, I would say this. So this year we also have a pack of updates for 5D surface. Let's take a look. First of all, the adaptive step, okay? You maybe know, I'm sure you know that it works not so well in many situations. Now, in certain situation, now it works much better. Let me just make a quick demo. So this is a typical situation when the toolpath is not good, okay, not consistent. For finishing, this is not what you want. So now you just enable adaptive step, and you have consistent toolpath throughout the surface, and it works for complex shapes, not only for simple shapes, okay? All these steep areas are now machined evenly, and you get the surface quality that you need. Next, barrel tool support, okay? Last year at the conference, in one presentation, there was a lack of barrel tool support mentioned as one of the main deal breakers for our dealers. So now we introduce barrel tool support for finishing. So let's take a quick look. Here we have the part. Yeah, okay. The curvature of this wall is 110 millimeters. Okay, and we will use. Let's go back. And we will use the barrel tool, which has curvature of 100 millimeters, so it's slightly less than the wall, okay? This is the barrel tool. Maybe you cannot see that this is the barrel tool on the screen because it's very, very big radius, but it's a barrel tool, okay? You can move the contact points, okay, right on the screen, like this, interactively also. And you can define the contact points in the inspector also here with the parameters. Let's also take a look at another thing. Here we have enabled the check holder, okay, so that when we make this machining, the tool is not touching the part. This is important. So let's calculate the toolpath. Okay, we have it. Let's take a look at the simulation. So with these big steps, okay, we can get now surface quality, required surface quality really fast. I think it's clear for you, okay, typical thing. But still, yeah, we can take a look at the verify compare and see that we have a very, very clean surface. And while the tool is moving down, now we can see that it comes closer and closer to the edge of the part. Yeah, it should not collide. And now the check holder will step in, and it will start inclination of the tool in a moment. Like this. Now you can see that the tool is working with its spherical part already. Of course, the surface quality at the bottom will be not the same, but this is the geometry of the part. This is how it goes. Okay. Next thing for 5D surfacing. Actually, it's not only for 5D surfacing, it's for any finishing operations. In many situations, you need to preserve sharp edges at your parts, okay? So you need to extend your toolpath to go a little bit more than required. And now you have the tool which you can use in a CAD section of the software. You just extend the surfaces and you can use it with any operation, not only with 5D surfacing. So let's have a quick demo of this. So in this part, I already have some extended surfaces. There are 3 different algorithms of how we calculate the surface extension. Okay. And you can use these surfaces for job assignments in the operations so that you calculate the operations relying on these extended surfaces. Okay. And thanks to the fact that these extensions are now located in the job geometry folder, they don't interfere with your parts, so you don't experience any problems. Just turn it off, okay, and continue working with other operations. Okay, here is the window. Okay, so I just can select the edge of some surface, define the distance what I want. Okay, here are the different approaches which you can use for surfaces extension depending on the shape of the particular surface. Okay, for example, you can use UV box. Okay, also with interactive elements like this. In many situations, this will save you a lot of time and to your customer. I see you're smiling, guys. Yeah, you like it. I like it too. Simple thing, but very important. Yeah. Okay. Okay, fine. Let's move on. Next thing about surfacing operation is before in version 1 we had only one option to define the stock. It was equidistant stock from the model. Now it's separated. You can separately define axial stock and radial stock. Okay, this is not something special, but you should know that it's there now in 5D surfacing operation. You have it. So let's sum up and move on. I would like to emphasize, also very important, that 5D surfacing, despite the name, it's the operation not only for 5-axis machining, but also you can use it for 3-axis, for 4-axis, and for 5-axis machining. So now we have adaptive step for better complex shape uniform toolpath. Okay, barrel tool support, surface extension, and separate stock allowances for radial and axial stock. So quite a lot of things, I think, and it's quite significant upgrade for the surfacing operation. Next topic I want to cover today is the additive manufacturing. Okay, additive manufacturing is a kind of newer niche, okay, newer solution. Of course, there are a lot of different solutions for additive manufacturing out there. Okay, and we also built our own proprietary additive manufacturing solution. Also very important. I always say proprietary because I know that it's so important to have a proprietary code, guys. You cannot imagine. Okay, so we developed ourselves some algorithms, which I will show you in a moment. What I want to say that we started early, okay, and thanks to this fact, we already can observe that in our license sales statistics, we have a lot of additive manufacturing licenses sold during last year, okay, and this is growing. We can see there is a potential. So, what's our take and our vision and our niche for additive manufacturing? This is non-planar slicing, okay, because planar slicing is something which is, we can say, solved. There are a lot of solutions for planar slicing. This is relatively easy. A lot of open source slicers, whatever, okay, for different materials, different processes and different applications, okay. But in our opinion, non-planar slicing is something where software now struggles, and there is a space for us, okay? There is a niche for us. At least this is how we can see it. Having the fact on the background that we have robot programming solution now with automatic robot access map, which is also important, combined with the non-planar slicing, we can provide a really high-end solution for additive manufacturing with robots. But also you can use all these things with 5-axis machines, of course, no problem. Okay, what I want to say also, that of course, apart from non-planar slicing, we also have planar slicing algorithms already, but this is not the topic today. So, in our non-planar slicer, we also have a pack of new features, and I think these new features are now moving it to the new level. First, when we introduced non-planar slicing last year, there was only possibility to use mesh models to define job assignment. Now you can select also the faces. You can use solid models for this. Okay, inside I want to say that they are still transformed into meshes. Okay, but with faces. When if you have your model with faces, okay, with solid model, the toolpaths are better and the calculation time is also better for faces. So that's it. Next, layer time. Okay, especially in the situations when you have this kind of part and each layer, the higher you go, the layer is shorter, shorter, shorter. The temperature is building up, and we need to control it. Okay, this is a specific requirement for additive manufacturing. Now we have a full-featured layer time option. Okay, you can define your desired layer time. You can define your minimum feed rate. You can enable or disable the delay option, so you can stop your additive manufacturing process, wait until the part is cooling down, and then continue. So this is it. And this layer time, what was the challenge actually with layer time? Because we have other thing, yeah, corner fit control. We had it in the milling section, but also it's available for additive manufacturing, but for different reasons, okay? Because the sharp edges, as you know, cannot be executed like in the control program, so the equipment is always slowing down in these sharp edges. And in order to provide a correct control program, we need to take it into an account and put corresponding changes into the control program so it can be executed and your part is the quality of additive technology is okay. And when we have corner fit control, it also influences the layer time. So we kind of blended all these algorithms together. They take into an account one another and work together very well. This is the challenge which we had in this area. Next, sorting. Okay, for milling, we have sorting by layers or by features. It's simple, okay? But additive manufacturing is a different area, okay, and it has its own requirements. And for additive manufacturing, we added a possibility to not only sort by one layer, but for whatever amount of layers you want. You can define, okay, say 10 layers, 5 layers, whatever amount. Now the toolpath is sorted. Okay, and this is important, for example, for this use case when you have some geometrical limitations, so you cannot build one feature and the second feature because it will not allow you geometrically. Okay, you will have collisions, so you have this flexibility now. Next, some interactive feature for layers, start and end points. Okay. So now you can define, okay, this is my starting point, just one point, and shift your connection points at every layer as usually, or you can use a spline, draw it on the screen, and this will be your connection curve, okay? This will be used for layers, start and finish. So, next, infill patterns. At first we had only lines. Okay, now we have also grid and triangles. We will put more different shapes here. What's important with to say about infills in non-planar slicing is that there is also a possibility to define the orientation, okay, independently from the walls. So you can change the vector and define the orientation of internal infills right on the screen interactively, very easy. I will show you in a moment. And also tool orientation options. Yeah. First, when we introduced non-planar slicing algorithm, it had only normal to surface. Now it has all 5-axis tool axis control options, like through point, through curve, through rotary axis, normal to surface, fixed, whatever you want. Okay. So let's have a quick demo. So here is the project, here is the toolpath, okay? So if I go to the machining, you probably can see these red lines, which are transitions. So they are happening every 10 layers, because here in the parameters, I have this split by layers set to 10. Okay, these are the layer sorting. What I want to show you is that now in the job assignment, we have also connection curve, okay? And actually, this is the spline. I can just take the point and right on the screen, I can change it like this interactively. Okay. Now I will recalculate the toolpath, and the intersection of this curve with the feature will be used to connect the layers. And if I go to simulation now, you can see that here is the new connection, like from layer to layer transition in this toolpath. So it's very easy to use, very intuitive, interactive. This is what we like. This is what how we do it usually. Okay. Next, let's take a look at the infill patterns, also interactive feature. Am I good at time? Okay, thank you. So, in the non-planar slicing, you have some different infill patterns, okay? Here we have lines, grids, and triangles. And we have this interactive arrow on the screen. You can just change the orientation. You can also define it more precisely if you need. Okay, and you have the preview already. Even before the toolpath is calculated, you can see how the infills will intersect the part and how they will be oriented inside the part. Okay, and if we make toolpath calculation, we can see now that I've made some changes. Okay, if we go to simulation and take a look at the toolpath. Let me turn off everything that we don't need. Okay, here is my infill pattern right now. Okay, fine. And the last thing I want to show is the layer time and corner fit control. So this is the part. Okay, I will just quickly, let's turn on the, like this. So you can see visually that in the corners, the toolpath is darker than in other areas. This is representing the slowdown, so that you can visually see that the corner fit control is engaged. And if we expand our toolpath, we can see, okay, every layer has its layer time at the beginning. And if layer 0 has 1000 seconds layer time, then layer 23 has already 300. And we can see here that the feed rate is also changed already, because here, for example, we had feed rate set to 200. Now in some subsequent layers, to keep this 300 limitation, we already slowed down the feed rate. And when it's not enough, okay, let me go here. For example, this layer already with a feed rate of 100 millimeters per minute has 290 seconds layer time. So in order to preserve and to fulfill 300 seconds layer time, we need to put a 10 seconds delay here. So I think this is simple things for you. You understand this very well, but it's critical for additive manufacturing. Next thing. So here comes the with the technology we finished, now comes some improvements in the workflow, and at the end there will be some interesting stuff. Okay, so please stay focused. So when we were analyzing the logs and which we receive on our server, which is showing us how users actually use our software, how they behave, and what is the time eaters, what are the time eaters for our users, we clearly understood that selection of job geometry sometimes takes a lot of time. You know all these things. You need to click a lot of surfaces. You need to click a lot of edges. Sometimes they don't connect properly, so you have to do trial and error, iterations, everything. So now we introduce the propagation thing, okay, propagation feature. It works based on the traditional propagation principle combined with feature recognition, okay? So like this, okay? You can just select now the area you want to machine very fast, okay? Or for example, the fillet is recognized, so you just can detect, it detects the fillet, and with one mouse click you can now select the whole fillet of the part instead of clicking to every surface. Or for example, the outer border of the part, okay? Or for example, the pockets, okay? And also, like this, I can, with a couple of clicks, I can select the pocket for machining. So it's a maybe not so complex thing to have in a CAD/CAM software, but still very important for time efficiency, and we remember that time efficiency is number one thing. Next, here comes the second version of ENCY Tuner this year, and we made some fundamental changes, I would say. First of all, we completely re-engineer the interface. Now it's more clear, and most important is that the workflow is now much more straightforward and automated. So you will have the users will have much less confusion on how to use properly ENCY Tuner. And second thing, the main bottleneck which we had for ENCY Tuner for the first year is the interpreters thing. Okay, interpreters problem. Yeah, you know this. Yeah. So now you can configure interpreter and customize an interpreter in a wizard very easy like this. Okay, and in a matter of couple of minutes you can change your interpreters and generate the interpreter you need for your particular customer, and that's it. We hope that with this update, with this upgrade, next year we will have a lot of sales of ENCY Tuner, because now it's much easier. It's night and day. Okay. So now in the interface on the left here, we have the ENCY code, okay? The simulation is on top there, so it's more clear, but still you have all the setup things, of course, and also the inspector with all the parameters, but it's now closed by default, so you don't bother with this from the beginning. If you need it, you can move it to the right, okay? Also change the size of it, of course. And in the middle, you always have your simulation. Okay. Also, the program explorer is now floating. Okay, on top of the interface, you can use a compare tool, and basically that's it. Let's have a quick simulation run. Okay. The most important thing about ENCY Tuner is the native compatibility with ENCY, but at the same time you can use it for third-party code, ENCY code management. This is a very powerful software for shop floor. And here's the interpreter configurator. You just choose your interpreter you want to configure. Okay, we have new interpreters. And with this window, you just define the parameters you want, okay, in your interpreter. Very fast, no coding required. Of course, it's not 100% no-code solution. You still will have to make some customizations, but it now became like night and day. Okay, 10 times faster, maybe 100 times faster, and less requirements for the skills. Okay. In the ENCY Tuner 2.0, we have new interface, okay, better, lighter, and most importantly, straightforward workflow now. And interpreters that are easy to configure. So we try to solve all the problems with ENCY Tuner which we experienced, and we believe that version 2 will go and we will have a lot of sales now. Fine. Along with configurable interpreters, this year we also introduced post-processors, which are also supporting configuration with this kind of screen. Of course, many of you know how to develop post-processors. This is not a problem for many of you, but in some situations, to customize the post-processor, you need to make some subtle changes, okay? And now you don't even need to make any coding. You just open the post-processor, make some changes, generate this post-processor, and after that you can make changes. What's important and what's good about this is all the post-processors that you generate with this wizard will be the same, okay? This is very important, because if you start making post-processors from ground, from zero, everybody is making their own approaches, and it's hard to make changes in the post-processor done by some other guy. Okay, now the main foundation of our post-processor is standard, and only customizations are different. Of course, we have old post-processor engine. Everything is no changes there. Okay, everything is still available and will be available, and we can continue development. This is a tool to make life easier when minor customizations are required. And the last topic, but it's kind of I would say how to say interesting. Okay, so we think, and we're not think, we're sure, we believe that AI topic is not a hype. Okay, this is a real thing, a real thing. Okay, and we started to embrace AI technology very early. Okay, in different areas of the business. in the products and in the business processes. Okay, now I will speak a little bit about what we have in our products connected with AI. The most important challenge and the biggest challenge with AI, integrating AI into the product, is safety. Okay, because customers don't want their data to be sent somewhere. Their 3D models, for example, can be classified or under NDA, so it's very important. And in our approach and our solution, I can say for sure, I know it, okay, that we do not send any customer data to our server. We do, how to say, in terms of AI, it's called vectorization. We make a vector for AI on the PC of the customer locally. Okay, we don't send it anywhere to make some AI stuff. And only after we made this change and this process, now after that we can send the data to our server, but it does not contain the part. Okay, you cannot see the part there. It's like something which AI is using, but not the people and not the 3D information. Okay, it's very important. So also, it's very important to say that in our opinion, the fact that we now make some AI research and development make our products future-proof, because I'm sure that all big companies are doing the same now. Okay, our advantage is that we are small and we are fast. Okay, we can do it faster. We don't have any bureaucracy in the office. Just do it and that's it. And since this year, we have a special dedicated team of developers who work only with AI features and integrate AI into our products. So, enough speaking, let's take a look at how it works. So here I have the parts, quite a complex mill turn part. It's like a lot of elements here, and now I can just add new operation and click auto generate. Now it does its thing. Okay, it's preparing model for AI vision. Okay, sending it to the server, making some changes. Making some like search, and now we have the process actually generated. Of course, yeah. Thank you. Look, we have lathe facing, OD wrapping, OD finishing, all the operations which we will really need for this part. Now I can change the job assignment quickly, like this, with a few tweaks. We will need 2D contouring for this part definitely, and pocketing maybe for these pockets, and 6D contouring also for these contours. Okay, all the necessary operations I have, okay, already. This is not a complete technological process, and at the end you see it put part of operation. So all is more or less correct. I can work with it and use it as a foundation, and to save me a lot of time. Okay, and with the several tweaks, I can also calculate toolpaths, okay, and see the result. I think it's really impressive, and we are going to continue this development because we can see that it works actually. Okay, what I want to say about this is that we need your participation. Okay, we need to collaborate with you, because the main thing to make the main thing we need to make this AI algorithm work better is the data. Okay, we need projects. We discussed with guys from Italy, other people. Okay, so we need more projects because we teach our AI assistant on the real projects or from the real customers with the real parts. This is very important. So the more projects you provide us, the better will be the result, and the better will be the sales, because the people will see this is a huge selling point in my opinion. So you can show it already, and it just works. Okay, and people, I think, will like it eventually. So fine. To finish the AI topic, okay, I told that we have a dedicated team. This is very important, who are working only on implementing and developing AI solutions for CAD/CAM. Very important that we do not send any information, any classified information to our server. We do like AI thing locally on the PC of the user. We install actually with ENCY now we install the neural network on the PC and it works locally. Okay, this is not a big network, not like ChatGPT. It's small. It's our own teached. Okay, we did teaching by ourselves. We always like make teaching with every update. It's better and better and better, and it works. It works locally on the PC of the customer. This includes not only milling and turning operations, but all other operations like welding, additive, painting, whatever. What operations do we have? We can use it for anything. So in version 2, we have much faster CAD import now. You may have experienced the problems with big not tool assemblies, but 3D model assemblies, okay, to import it in our software. Now it works in parallel processing, and in cases when you have a big assembly and you import a huge chunk of 3D model into ENCY, and now it works 50% faster than before. So let's meet ENCY 2.0. Thank you. Thank you. The last thing I want to say about ENCY 2.0. So we have official debut on EMO at EMO Hanover in September 2025. Okay. Those of you who can attend it, please be there. Okay. This is a commercial release. And sales launch is right after the exhibition.